We propose HaptoFloater, Visuo-Haptic augmented reality by embedding imperceptible color vibration signals for tactile display control in a mid-air image. This system ensures spatial consistency between visual and haptic information. We use imperceptible color vibration to embed information for controlling devices to mid-air images. Imperceptible color vibration takes advantage of the human characteristic that when two different colors of the same luminance are displayed alternately and switched at a rate of 25 Hz or faster, humans perceive the intermediate color. By utilizing this technique, imperceptible signals can be embedded in images. Then let me give you an overview of this system. We first create two color vibration images. By displaying these images alternately, imperceptible signals are embedded in each pixel. We preloaded tactile vibration patterns to a haptic device. With a mid-air image display, the image is presented as a mid-air image. When a user scans the mid-air image, the device provides haptic sensations corresponding to the position. In a haptic device, a photosensor receives a color vibration signal and sends it to a microcontroller. The microcontroller sends a tactile vibration pattern to the actuator according to the receiving information. We have developed a wearable haptic device controlled by imperceptible information. It comprised of a photosensor, a controller, and an actuator. We conducted two user studies. The first one is a latency tolerance user study. This aims to investigate whether users would notice a latency between visual and haptic sensations while using the system. We conducted two types of perceptual threshold assessments. Perceptual threshold for delay when changing from no tactile information to providing tactile information, which is a turn-on condition, and vice versa, which is a turn-off condition. We identified the threshold values for the acceptable delay time for visual and tactile perception. This was defined as the time at which the user perceived a delay with a 50% probability. The results indicated the threshold is approximately 110.6 milliseconds in the turn-on condition and 112.3 milliseconds in the turn-off condition. The total delay of the system is 59.5 milliseconds in the turn-on condition and 46.5 milliseconds in the turn-off condition. Since the delay perception threshold is significantly larger than these, the proposed system meets the requirement of having a latency that does not allow the user to perceive the Visuo-Haptic latency. The second user study was conducted to investigate how the user's perception of the reality of the texture varies depending on the presence and appropriateness of the tactile presentation. The mid-air images were 5 different textures. We used 3 types of tactile presentation. The results showed that the texture vibration condition was significantly higher than the no tactile sensation condition. Thus, we found that presenting texture vibration is an effective method for presenting realistic Visuo-Haptic textures.